11.49 involves an athlete who pulls handle A to the left at a constant velocity of 0.5 meters per second. It wants us to determine the velocity of the weight B and the relative velocity of B with respect to the handle A. Since this velocity out this way, I'm going to designate it 0.5 meters per second. I'm going to let that be the plus x direction to the left. That's going to be the same speed that a point D on this line over here would have. And I'm going to let positive be downward here. So if this speed right here is positive that way, then the speed of D is actually this direction, which would be a negative. So that means the velocity of D is going to be a minus 0.5 meters per second. And then L right here is going to be a constant. We're going to mark the positions x sub D and x sub B then here in this on this diagram. The length of the string from D around to C is a constant length, okay? And so to get that length, we would take the position of B right here and subtract the position of D to get this length right here. So it's x of B minus x of D then equal to that. Plus, then we have 3 of these across here that are 3x of B's. And then we have, to within a constant, these 2 right here are just 2 times the length of this system here. So this is a constant, that's constant there. You take the derivatives with respect to time to get the velocities. You got 4 of these x sub b, so you're going to have a 4 v sub b, and then you're going to have a minus v sub d, and it's all going to be equal to 0 then. When you solve for b out of here, it's going to be v sub d over 4. V sub d is minus 0.5 divided by 4, minus 1.25 meters per second then is your answer. Now to do the velocity of b with respect to a, you need to write out the vector of velocity b minus the velocity of a, since they're in different directions. And so what we have for the velocity of b was a negative 1.25 meters per second j. So in other words, it is moving upward, but that's the opposite of our positive j direction. And then you got a minus sign, and then v sub a is a positive 0.5 meters per second times the I unit vector. So when you take the square root of the sum of the squares of the 2 components right there, you'll get 0.515 meters per second. And when you do the inverse tangent of the j component divided by the I component, then you'll get 14.04 degrees. And since both of these terms are negative, that means it's in the negative x and the negative y, which is that way, so it's off in this direction right here of 14.04 degrees above the negative x axis.